Hello everyone, let us solve some problems on bivariate probability in this video. Let us consider the first problem. The random variable u has a mean of 0.3 and a variance of 1.5. Find the mean and variance of y if y is equal to 1 over 53 summation I value varying from 1 to 53 u of I. Second one, find the mean and variance of z if z is equal to summation I value varying from 1 to 53 ui. In these two sums, the ui's are IID. Y is equal to 1 over 53 u1 plus u2 plus u3 so on up to u plus u53. So we'll apply the linearity property here. And we know that mu y is equal to 1 over 53 into expectation of u1 plus expectation of u2 up to plus e to the e expectation of u53. That is 1 over 53 multiplied by 53 multiplied by e of u1, which is mu u. So the answer is mu u, that is equal to 0.3. U gives rise to sigma u square. So u by 53 should give rise to sigma u square by 53 whole square. So we can get sigma y square is equal to variance of u divided by 53 whole square into 53. That gives you 1.5 divided by 53, 0.0033. That is given by u1 plus u2 up to u53. So mu z is equal to e of mu1 plus e of mu2 up to e of mu53. So therefore 53 into 0.3 is give you 15.9, that is equal to mu z. Sigma z square is equal to variance of u multiplied by 53. That is 1.5 into 53, that is equal to 79.5. Let us consider the second problem. The random variable x has a mean of 12.6 and a variance of 2.1. The random variable y is related to x by y is equal to 10 into x minus mu x. The random variable z is as shown here. Z is equal to summation I value is equal to 1 to 100 yi, where yi's are IID. What are mu z and sigma z square? Let us try to solve this. Given y is equal to 10x minus mu x, let us apply the linearity property. According to linearity property, mu y is equal to, it is 10 into e of x minus e of 12.6. So e of 12.6 is equal to 12.6. So therefore we can write that as 12.6, and e of x is equal to mu x. Since mu x is given as 12.6, 12.6 minus 12.6, that gives you 0. Similarly, we can find out sigma y square, that is a variance of y is equal to variance of 10 x minus mu x, that gives you 10 square sigma x square. Here sigma x square, variance of x is given as 2.1. So it is 2.1 into 100, that gives you 210. And if you observe here, z value is given as summation of I value varying from 1 to 100 yi. That means this is equal to y1 plus y2, y3, so on up to y100. Now since all yi's are same, so we can write here it is e of y1 plus e of y2. It's a linearity property up to e of y100. Similarly, we can write for variance. So therefore, we have sigma z square is equal to 100 times sigma y square, and it is 100 into 210, that gives you 21,000. Let us solve the third problem. The random variable x is equal to 3 plus v, where v is a Gaussian random variable with the mean of 0 and variance of 30. 72 independent realization of x are average. So y is equal to 1 over 72 summation I value varying from 1 to 72 xi. What are the mean and variance of y? So let us try to solve this. Given x equal to 3 plus v, that's written here. So let us take the expectation on both sides. So we have expectation of x. Applying the linearity property, we have expectation of 3 plus expectation of v. Expectation of 3 is a constant, so 3. Expectation of v, the mean of Gaussian random variable is given as 0, so therefore it is 0. So we get this equal to 3, that is equal to mu x. Mean of x. Let us try to find out sigma mu y. The mu I is equal to, here if you see this is equal to, we can write y equal to 1 divided by 72, it is x1, x2 up to x72. So this is equal to x into 72 divided by 72, because we have assumed it as to be identical. So therefore we can write here mu y is equal to mu x into 72 divided by 72, that you get mu y is equal to 3 into 72 divided by 72, that is equal to 3. Similarly, we can find the variance. Variance of x is given as 30. So sigma x square equal to 30. Variance of the constant term 3 is going to be 0 and sigma v square. So we can find out from this sigma x square is equal to 30. So therefore sigma v square, that is variance of v, is also equal to 30. And using the equation sigma y square is equal to 30 divided by 72 whole square into 72. This relationship is given by, this is always equal to sigma x square divided by 72 whole square, and totally there are 72 realizations. We get this as 0.4166. Consider the fourth problem. The random variable z is uniformly distributed between 0 and 1. The random variable y is obtained from z as follows. Y is equal to 3z plus 5.5. 100 independent realization of y are average. So u is equal to summation I value varying from 1 to 100 yi divided by 100. A. Estimate the probability P, the probability u less than or equal to 7.1. B. If 1000 independent calculations of u are performed approximately, how many of these calculated values for u would be less than 7.1? Mu z, mean of z is given by a plus b by 2, and here it is a is 0, b is 1, so therefore we get 1 by 2. And the variance of z, sigma z square is given by b minus a whole square by 12, that is equal to 1 over 12. And in order to find mu y, we will take expectation on both the sides. Expectation of y is equal to, we can write this as expectation of y is equal to 3 times expectation of z, that is expectation of 5.5. And here expectation of z is given by mu z, and expectation of 5.5 is given as 5.5. So therefore it is mu y is equal to 3 times mu z. plus 5.5, that you get 3 into 1 by 2 plus 5.5, that gives you 7. Similarly, we can find sigma z square, that is sigma z square is equal, sigma y square is equal to 3 square into sigma z square. So that is equal to 9 times into 1 by 12, that is 0.75. So here we can write mean of u is equal to 100 times mu y, that is mean of y divided by 100. So that's why you get this equal to mu y. So therefore mu u is equal to mu y, that is equal to 7. And here we can observe it is sigma u square, that is the variance of u, sigma u square, that is variance of u, is given by, it is sigma y square by 100. So you have 0.75 by 100. So you get this as 0.0075. So from this you can find out sigma u, square root of 0.0075, that gives you 0.0866. Probability of u less than or equal to 7.1 is equal to 7.1 minus 7 divided by 0.0866, that is 1.154. Refer the table. From the table we can get phi of z equal to 0.8749. So therefore for 1000 independent realizations we need to multiply this 0.749 with 1000 to get 875. Let us consider the fifth problem. Joint PDF fxy is given as 1 divided by 1.90795 exponential minus x square minus 0.6xy plus y square divided by 1.82. Find the PDF of y conditioned by x equal to 3. Find the mean and variance of y conditioned by x equal to 3. Fx of x is given by e to the power minus 0.5 x square divided by 1.414 root 5, that is equal to e to the power minus 0.5 x square divided by root 2 5. Fy of y condition with y given x is given as fxy of x comma y divided by fx of x. So that is equal to 1 divided by 1.90795 exponential minus x squared minus 0.6x5 plus y squared divided by 1.82 e to the power minus 0.5 x squared divided by root 2 pi. On simplification, this reduces to the form 1 divided by 2.392 exponential minus 0.09 x square plus 0.66y minus y square divided by 1.82. Let us write it as fy y given 3. We will replace wherever x is there in this equation by 3. So when we replace this and simplify, we get this as 1 divided by 2.392 e to the power minus 0.81 plus 1.8y minus y square divided by 1.82. So 1 divided by 2.3992 exponential minus y minus 0.9 whole square divided by 1.82. So therefore we can write mu of y given 3 is equal to integral of y into fy y given 3 dy. So when we integrate this, we can get the final answer. Let us write this as minus integral of minus infinity to infinity y divided by 2.392 e to the power minus y minus 0.9 whole square divided by 1.82 dy. U divided by root 2 is given by y minus 0.9 divided by root of 1.82. Simplification gives us u into root of 1.82 divided by 2 is equal to y minus 0.9. So let us make the substitution and then integrate. We get mu y11 3 is equal to 1 divided by 2.392. It is u into root of 1.82 by 2 plus 0.9 du e to the power minus e square by 2. On simplification, we get this as 0.9434. Similarly, we can find the variance sigma square y given 3 is equal to integral of y minus mu of y given 3 whole square fy y condition with x dy. So when you simplify this further by substituting u by root 2 is equal to y minus 0.9 by root of 182. So du is equal to root of 1.82 by 2 is equal to dy. So we have y is equal to u into root of 1.82 by 2 plus 0.9. So we can write y minus 0.9434 as u into root of 1.82 by 2 minus 0.0434. Finally, let us substitute it in the integral sigma y square y given 3 whole square integral of u into root of 1.82 divided by 2 minus 0.0434 whole square 1 divided by 2.392 e to the power minus e square by 1.82 the root of 1.82 divided by 2. Let us simplify this further using the gamma function. So when we use the gamma function, we get it as for the first one is u square, second term is u, and this is 1. So we know that for the even term, it is going to be, values will be there. For odd term, they are going to be 0. So therefore, the gamma function for this is 0. So we have to consider only these two functions. So therefore, we have 1.82 by 2, 2 to the power 3 by 2, gamma of 3 by 2. And here 0.0434 whole square, 2 to the power half, gamma of half. Further simplification will give us 0.91187. Thank you. With this, we are completing the module number 2. Let us move on to module number 3, probability in case of random process, in the next video.